Okay, so today we will be covering all things linear functions. Yeah, that's it. That's the tweet, I guess. So the first thing we'll cover is slope. For those of you who've taken algebra before, should be reviewed. For those of you who are new to this, welcome. It's pretty easy. Okay. So first, what we're going to do is we're going to define what slope is. Okay. So slope can be defined as the ratio of the change in the y value divided by the change in x. Okay? Change in y divided by change in x, the ratio of the change in y relative to x. Different ways to look at it. You can call this delta y divided by delta x. Delta just means change, right? Some of you might remember this as rise over run. All are valid, all are fine. Yeah, okay. So the second thing we'll do is we'll talk about the slope formula, okay? So given a pair of points, given 2 points, so they have to be in the form of an ordered pair, right? We can call it x sub 1 comma y sub 1. These are ones, okay? So x sub 1, y sub 1, right? And your second point we can call x sub 2 and y sub 2, right? The slope of the line between these 2 points, so suppose your point is like here and here, we draw a little line between them, like that, right? The slope between these 2 points we've written as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, okay? You notice the x and y coordinates are paired up. Please don't mess that up. That will completely change your slope and your answer will be wrong, okay? And this is also called n, okay? So the shorthand for slope is also called n, okay? And again, right, we talked about how this is a ratio of the change in y divided by change in x, and you're going to find that it makes perfect sense. This right here, right, if we consider this as a triangle, right, like that, and like this is x1 comma y1, and this is x2 comma y2, right? Well, naturally, to see how high up you go, you take delta y for height, I'm so sorry, and then going this way, right, you'll get delta x. Okay? So rise over run. It's pretty straightforward, no notes. Okay? When we talk about lines, right? When we talk about lines, we have a couple different kinds, right? You know, you have lines that intersect and you have lines that don't, right? Among the lines that intersect, you can have them intersect like this, you know, you get some weird angles over here, right? Or you can get lines that intersect like this, where you get a perfect right angle. And if you remember, these are called perpendicular lines. Okay? And if you consider this line 1, and you consider this line 2, right? One of the properties of perpendicular lines is the following statement. Oh no! Alright, there we go. Line 1 and line 2 are perpendicular. Sometimes I'll write it like this for short. If and only if. Okay? That's what this means. This means if and only if. So this side implies this side, and this side implies this side, okay? M1 is equal to, no, try that again. If and only if M1 is equal to -1 over M2, where M1 is slope of L1 and M2 is slope of L2. Okay, that's how you can determine if these two lines are perpendicular. Okay, so that is perpendicular lines, and I'll label this for you guys as well so you get confused. Okay. Again, if L1 and L2 are perpendicular, or L1 and L2 are perpendicular if and only if the slope of L1 is equal to -1 over the slope of L2. Okay? Cool. The second interesting set of lines are lines that don't intersect, parallel lines, right? And we can say L1 and L2 are parallel if and only if the slope of L1, which we call M1, is equal to the slope of L2, which we call M2. Again, pretty straightforward. It is what it is. Yeah. So those are properties of particularly special and interesting to us. That is it for chapter 2.2. Okay, friends? In terms of problems, I want you guys to work out the following, okay? One, and this is a question for me, is x1 minus, oopsies, is y1 minus y2 over x1 minus x2 equal to y2 minus y1 over x2 minus x1. Prove why or why not. Proof by example is not an option. Okay? So what I mean by that is, if you say, for example, prove an even number plus an even number is always even, and my solution is 2 plus 4 equals 6. 6 is even. Can't do that. What I can do is I can say, oh, let 2a and 2b be even numbers, right? Right, because even numbers are always able to form 2 times something, right? 2a plus 2b is the same as saying 2a plus b, and anything of the form 2 times blank, as long as that blank is an integer, is always even. This is okay. All right? Okay. So, no proof by example. So in terms of questions I want you guys to work on for this, for chapter 2.2 from the textbook, I want you guys to look at, let's see, let's do numbers, oh, and you're on page 50, okay? It's just the practice review section. I want numbers 14 through 18. I want 28 through 30. I want 32. Ooh, I want 33, so 32 through 33. I'm gonna cut that. I want you to answer, I guess this is question number 2 from Amanda. What are the slopes of a horizontal line and vertical line? And that's important because then after this I want you guys to do number 42 and 43. And I want you to do numbers 53 through 55. Okay? Feels like a lot. Promise you it's not. If this was an actual classroom, we'd be working these out together anyway. Alright? So that is it for slope of a line. We're going to move on to 2.3 now. Okay?